All right, so here's part 2 of section 1, and we're going to be talking about systems of equations with applications. So I think this first problem here really kind of sets the stage for what we're really doing. All right. And a lot of these problems are going to have the same exact theme, which is kind of like if you think about it as like a mixture type problem or mixing two quantities together. All right. So if you want to go ahead and pause the video, you can write this down or you could just follow along with us. But here's the first one here. A biologist has two brine solutions, one containing 2% salt and another containing 8% salt. How many milliliters of each solution should be mixed to obtain 1 liter of a solution that contains 5.6% salt? So here's what's happening here. We have our first solution, all right, and this is going to be 2%. And then we have a second solution here, and this will be 8%. Okay? The goal of this is to take each of these, mix them together into another container that is 1 liter of 5.6% salt. Okay? So as you could tell here, the percentage that you want is in between the 2 and the 8. So we're not going to mix equal portions of this. We're going to figure out how much of each do we need. So in all of these equations or all these problems, you really got to think about what's really happening here. Notice that we have two completely different types of solutions here. We have 2% and 8%. Since they are different, and I don't know how much of each I'm going to need, I'm going to label this X and this Y. Now, what I do know is this. I'm going to take some of the X, which is the 2%. I'm going to take some of the Y, which is the 8%. And I need 1 liter or 1,000 milliliters of that. Okay, that's what I definitely know. So we call this the amount equation, okay? Now, you have two variables, so you're going to need two equations. So here's our second equation. Now, our second equation is going to be the percentage or the constraint equation, all right? And I'll write that in a second here. But here's what we know. We know of the first solution, it's going to be 2%. And I'm going to add that to my 8% solution. And I have to total 1,000 milliliters at or of 5.6%. Now remember, we never use percents. So this is going to be 0.056. And like I said, we can call this our percentage equation. All right. So in essence, here's what happened. We're going to let X equal the amount of 2%. We're going to let Y equal the amount of 8%. And we know we're going to combine them to give us 1,000 milliliters. And then these concentrations also have to balance out to 1,000 times 0.056. So what I'm going to do here is I'm just going to rewrite my system real quick as X plus Y equals 1,000. And then 0.02X plus 0.08Y equals 56. Because remember, 1,000 in the upper right hand corner of your screen, 1,000 times 0.056, you move the decimal place 3 places to the right. So here is our system that we're going to have to solve. And you can do this any way you want. You can do it using graphs. You can do it using the substitution method, addition elimination method. I'm going to go ahead and solve this by hand, but I'm going to go ahead and use my substitution method. So I'm just going to go ahead and pick the first equation. I'm going to solve it for Y. So Y is going to equal 1,000 minus X. Then I'm going to take this and substitute it into the equation that I didn't pick. So 0.02X plus 0.08. Make sure you put this quantity in parentheses. And that has to equal 56. So from here, I'm just going to go ahead and just do basic math, solving linear equations. So I'm going to distribute 0.08 times 1,000 is going to be 80 minus 0.08x equals 56. Now I'm going to group my like terms. So 0.02 minus 0.08 is going to be negative 0.06x plus 80 equals 56. I will subtract 80 from both sides. So that's going to give me negative 0.06x equals 56 minus 80 is negative 24. And then finally, I will divide both sides by negative 0.06 to give me x equals 400 milliliters. And remember, we let x equal the amount of 2%. So 400 milliliters of 2% brine solution. All right, but that's only half of the problem here. Because we figured out how much of the 2% we need. How much of the 8% do we need? Well, remember, if I scroll up here, we let y equal the amount of 8%. And then, when in the process of us solving this, we use the substitution method. Right here, we have y equals 1,000 minus x. So I can come down to here and say, well, y is going to equal 1,000 minus 400. So y equals 600 milliliters of 8% solution. And that's it. That's how we solve these problems. So honestly, the hard part, just like any other word problem, is to think about what's happening here, okay? Setting up your system. But once you get your system set up, like we have right here, it's kind of like a downhill from there, all right? So let's go ahead. Let's look at the next example I have for us. So in this example here, we have a gas station that sells regular gas for $2.25 per gallon. I wish, especially today. Maybe this is a bad problem to pick. I'm sorry. All right, so let's just start over again. A gas station sells regular gas for $2.25 per gallon and premium gas for $2.85 a gallon. At the end of a business day, 300 gallons of gas had been sold, and the receipts totaled $729. How many gallons of each type of gas had been sold? Now, although this is different from the previous problem, it's still a mixing problem in its truest form, because we have some of the regular gas, and then we have some of the premium gas, and the sales are mixed together for a total of $729. So let's go ahead. We're going to let x equal the amount of regular gas. We're also going to let y equal the amount of premium gas. And here's what we know. These two together, those amounts, they got to total up to 300 total gallons, because that's how many we sold that day. But now we need another equation to figure out how much of each did we have. And that's where the percentage, or in this case, it's going to be the dollar amount equation, kicks in. We know that regular gas is $2.25 a gallon. So that's going to be 2.25 times x, plus premium gas is going to be $2.85 times y. And that has to equal 729 total dollars. So here's our system right here. And we can use any method we want to solve this. Once again, I'm going to go ahead and use the substitution method, because that first equation is just so nice. And it's going to make our life much easier. I'm going to solve for y again. So 300 minus x. Put a box around that, because I know I'm going to use that later on. Oops, sorry, you can see the second problem, or our last problem here. So give myself a little bit of space. So let's see here. We're going to take this, and we're going to substitute it into the equation that we didn't pick. And I'm going to write it to the right here. So we have 2.25x plus 2.85 times the quantity. 300 minus x has to equal 729. Now from here, we just go ahead and solve. So we get 2.25x plus 2.85 times 300 is going to be 855 minus 2.85x equals 729. Now I'm going to go ahead and group like terms. So 2.25 minus 2.85 is going to be negative 0.6x plus 855 equals 729. Now I will subtract 855 from both sides. This is going to give me negative 0.6x equals 729 minus 855 is negative 126. And then finally, we will just divide both sides by negative 0.6 to give us x equals 210. So, how much of the regular gas did we have? I write it in red. 210 gallons. All right, and then for y is going to be 300 minus 210, or 90. So how much of the premium gas? 90 gallons. Okay? So I hope this is making sense. Every single problem that we approach is basically the same way. You just create your equations, and then you choose a method. Now, the last problem we have, this one is just going to be a little bit different, all right? And the reason for that is we're still going to create a system, except our equations that we create are going to be dependent on the application that we have. All right, so a small plane flew from Fargo to Bismarck, North Dakota. Both of those cities are in North Dakota, which is a distance of 180 miles. Now, because the plane is flying into a headwind, the trip takes 2 hours. On the way back, the wind is still blowing the same speed, so the return trip is 1 hour and 15 minutes. What is the plane speed in still air, and how fast is the wind blowing? All right. So in this problem here, we need to take a step back and we need to think about, all right, what are they asking us for? So that comes from the very last sentence. They want to know plane speed, and then they want to know how fast the wind is blowing. So we're going to let x equal the plane speed, and we're going to let y equal our wind speed. Okay? Now, anytime you read a problem and you see distance, you hear the word speed, and you see like a time, we're going to have to incorporate distance equals rate times time. Okay? So if you think about it here, we have 2 trips, which means 2 equations, which means 2 variables. So everything's kind of lining up here. Our first trip goes from Fargo to Bismarck, and then the return trip is the same distance. So we know that distance is 180 miles. That doesn't change. That's from the first sentence in this problem. It's everything in between the first sentence and then the last sentence that we need to be concerned with. So if we think about this here, we know the plane is flying into a headwind, which means the wind is moving in the opposite direction. So the plane speed and the wind speed are going to be opposite each other. So x minus y. All right. So this is going to be from Fargo to Bismarck. Okay. And this actually represents the rate at which the plane is flying into the headwind. Okay. Then we have the return trip. So the return trip is going to be x plus y because the wind is actually pushing the airplane. So this is going to be from Bismarck to Fargo. And this is also a rate. So we have our two equations, and we have everything that we need here to set this up. Because once again, we need to think about this in terms of distance equals rate times time. So here's our two equations. The first one is from Fargo to Bismarck. We know the distance is 180. We know the rate, x minus y, and we also know how long that took. So from Fargo to Bismarck, it was 2 hours. So this is going to be the quantity x times y times 2. Then from Bismarck back to Fargo, we know that distance. Well, that distance is 180. And that's going to equal our rate, which is the speed of the plane and the wind, because it's pushing it, times 1.25 hours. Now, if you're wondering where I got the 0.25 from, let me highlight it here for us. So right there is the return trip. It's 1 hour, 15 minutes. 15 minutes is 1/4 of an hour. So 1/4 is 0.25. All right. Now we have our system. So I'm just going to go ahead. I'm going to rewrite our system here. I'm just going to write it to the lower left. So we have, and I'm going to write it nice and neat, 2 times the quantity, x minus y equals 180. And then we have 1.25 times the quantity, x plus y equals 180. Now I'm going to go ahead and just use basic math. I'm going to distribute the 2 first. 2x minus 2y equals 180. And 1.25x plus 1.25y equals 180. And then from here, I need to figure out a method. Whatever method you want to use, that's fine by me. I'm going to go ahead and use my good old substitution method because it's so easy when you're doing these problems. So I'm going to take the very first equation, and I'm going to solve it for, I'll solve it for x. So it's going to give me, I'll just write it out. So first thing I'm going to do is add 2y to both sides, and then divide everything by 2. So that's going to give me x equals 90 plus y. Okay? So right there, I know is my plane speed. How do I know that? Well, upper left-hand corner of your screen, we said x equals the plane speed at the very start. All right? So now from here, we're going to take x, and we're going to substitute into the equation that we didn't pick. So 1.25 times the quantity, 90 plus y, plus 1.25y equals 180. And then from here, it's just a matter of solving. So let's go ahead and distribute. 1.25 times 90 is going to be 112.5 plus 1.25y plus 1.25y equals 180. 1.25 plus 1.25 is going to be 2.5. So this is going to be 2.5y plus 112.5 equals 180. Now I'm going to subtract 112.5 from both sides of my equation. That gives me 2.5y equals 180 minus 112.5 is 67.5. And I'm just going to write this right over here so I have a little bit more room. 2.5y equals 67.5. Finally, I will divide both sides by 2.5 to give me y equals 27. And remember, if I scroll out here, we let y equal our wind speed. So 27 miles per hour is the wind speed, which means our plane speed, which is directly above, is going to be x equals 90 plus y. So x equals 90 plus 27 which is going to be 117 miles per hour, and that's our plane speed. All right. And that's going to be it for this video. Like I said, these systems of equations are straightforward. It's just you got to take a step back and you got to think about what's happening in the problem. If you need a formula like the distance formula, a nice little picture, what I have here just from Fargo to Bismarck and then Bismarck's back to Fargo helps. Sometimes you don't even need that, like in this case, which is the gas station. All right. And other times it's nice to draw like a little picture, and that would be the last problem, which is our biologist with the brine solution. All right. So good luck. If you have any questions, just let me know.